identified that, documented it, and a proposed way of preventing it occurring in any new buildings. So let's jump on to the next slide. These are the sections I'm going to be talking about. Firstly, looking at the process by which the government architect in New Zealand developed the post-occupancy evaluation method, as we call it, evaluating buildings in their first year or two of occupancy, of use, and the stakeholders that we involve in that, and some of the lessons learned that we have identified in that. And I've also got a few questions for the audience in this, so I'm interested in your responses too. I'll then discuss this business of the hazard, which has come up, and the characteristics of that hazard and what might have caused it and how it could be prevented in future systems if we had a due diligence process to prevent this occurring in any new buildings. As I said, I've got 3 questions through this talk, which would be interested in your responses. Hopefully they're helpful to you as well. These are general opinion, of a nature of general opinion rather than any specific technical knowledge. So in quality management, you may be familiar with Edwards Deming's quality cycle, the PDCA cycle. So it can be applied to buildings or any other sort of process, planning them, building them, checking them out, which is what we do in this post-occupancy evaluation method, and then taking some actions to apply the lessons learned. And of course, in buildings, they get a little bit more complicated with productivity and well-being, relying on the building itself, plus the ways it's used by the user population and the conditions under which they are used. And by conditions, I mean, of course, day-night cycles, weather conditions, climate, and so on, climate variables, but also things like times of maintenance austerity, which could affect a building through its life of typically 50 or 100 years. It might also be things like security conditions or social unrest or times of public health emergency, such as we have at the moment. And the buildings need to perform reasonably well in all of those conditions. So we can ask the question, who are the experts on the experience of these buildings, and whether people are able to achieve their productivity and well-being? And the answer to that was really given by the government architect when they set up this process with Victoria University and several government departments, and that is that each stakeholder is best equipped to describe their own experience of the building and how the work and well-being is supported or frustrated by the design. Now, so that includes the employees in a building, their clients, in other words, the people that they serve. So, for example, that could be patients in a hospital or students in a university or a school, and people coming to use services, hotel guests or restaurant guests and such like, people that come to use their services there. And it includes the maintenance people, who are often very well informed about any building defects and areas needing maintenance attention. Of course, the project team, and we also consider future generations who will be affected by the environmental impacts of the building operation and construction. And this business of being stakeholder-centric is taken quite well by the New Zealand method of post-occupancy evaluation, where we use an objective prompt. So rather than the evaluator, such as myself, suggesting what the topics are, we use the building to provide a spatial agenda and a neutral prompt, because we believe that if you listed all of the topics in a building, you would have thousands of questions, which of course is impractical to ask. So we just want to focus on the areas which need special attention, and often there are thousands or hundreds and hundreds of issues which are in design decisions which are working perfectly in new buildings, and they do not need further attention. So it also gives the ability to focus on specific elements rather than a whole class of element like a window system or a door system or flooring systems, and for the stakeholders to negotiate building use and conditions solutions to building use conditions problems. So after the government architects set that process up, they ran about 20 evaluations of various government departments, and since then I've applied it on approximately 190 projects involving hundreds of buildings, and that includes most types of public buildings plus various commercial ones like in retail, apartments, and healthcare buildings. And we've done most of those in New Zealand, with quite a lot in Australia, a number in Scotland, and a few other European capitals, including the Arctic in Norway there, and in Moscow. So typically a sort of medium-sized evaluation will yield maybe 50 to 100 topics. And some of those, if we look across the various evaluations, will be what I'd call relatively common lessons learned, which are repeated. So these are things that we are not learning in the building industry, or you might say problems that are repeated, such as the slippery entrances, which we'll speak about in a moment. Now, the nature of these problems seems to be that they're quite expensive to repair and to pay for the downstream costs of. They tend to be international because I've seen these same sorts of problems occur in overseas evaluations, and they don't seem to be new. Some of them, such as slippery entrances, are possibly thousands of years old, but we keep building it. Another thing about them is that the physics of them is pretty simple. You know, it's not rocket science to know when an entrance is slippery when it gets wet. It's simple friction, simple matter of friction, and yet we keep getting it wrong. And we also know the solutions to it. So these are not that we technically do not understand or we do technically understand the solutions, but for some reason we keep building them. Here is a sign that I photographed in one major public building evaluation recently. The building was 5 years old. I was told that a couple of people fall over every week in winter by one of the people that works near the entrance. And recently a staff member fractured their pelvis on this. It's still not repaired after 5 years. But of course I recommended the repair in the evaluation. Here's another example, a major public building in a university, where the people running across the campus on a wet day would find themselves running into this entrance with a slippery floor to get out of the rain as quickly as they could. Apparently some of them fell over, and naturally I recommended repairs, and the client repaired the floor, so it made it safe, and there were no serious injuries. A typical maintenance response or facilities management response to slippery when wet entrances is to place warning signs around the area and place rubber mats over the part of the slippery when wet floors. Here's some signs. If you Google images of slippery when wet, you'll see a whole vast array of signs. So it's a big problem that's created this downstream niche industry of slippery when wet signs and banana skins. Here's an example in Wellington City, where you can see the hazard underneath the mats and the engraved slippery when wet sign on the floor. Those of you in Auckland might recommend the western entrance to Newmarket Station. I was doing some evaluations there, and just near there, and I noticed the railway staff or the transport staff rolling out these mats each morning over part of the slippery when wet floor. And also there was a blind man came past it when I was taking some photos, but of course he can't read the signs, so he's more vulnerable than most of us. So we seem to not notice these signs. We seem to be seem not to notice this hazard at all. We've just got so used to it, and it's even crept into this web page of an organisation purporting to promote the idea of housing which can be used throughout people's ages, right into the elderly housing. And they've got a slippery when wet entrance there, partially covered by mats. So there seems to be quite a big degree of tolerance or maybe lack of awareness of it being a hazard. So I'm interested in your thoughts. Are these slippery when wet entrances with warning signs and mats good enough? So perhaps you'd like to just put some thoughts on whether you think that's okay or not okay. Would you be happy for your family to be crossing these entrances or not? Okay, pretty much all no so far. 23 people no, just one person saying yes. Yeah, that's pretty much what I thought. So let me move on now to uh, look at this further. I want to talk about another example which made the front page news of the Otago Daily Times, and that is a university building where there was 12 serious injuries reported over a period of 18 years. And eventually it was repaired at a cost of $18 million for the repair project, and of course a lot of injuries and misery and lack of productivity by the people affected by the accidents. Here's a photograph of part of that entrance. As you can see, it's a foyer with a mezzanine level, and there was an entranceway both to the upper level and the lower level at a sloping site. You can see in the foreground there are slippery when wet tiles. There's a floor outlet, a drain to take the water away. They were obviously planning for that. And you can see the sign up on the glass balustrade there. So water could come in during conditions of wet weather on the bottom of people's shoes. It could come in through holes in the roof because the roof leaked, which is, by the way, another relatively common lesson learned. And around this mezzanine, there was one fire hose reel on each of the four sides of the top. So a fire hose reel could possibly leak, I guess, or it could be used in a student prank to attract attention of other students down on the lower level, perhaps. Or worse still, it could be used in a fire. You could imagine somebody turning the hose on, moving towards the fire, and as other people are running away. So you've got conditions of panic, which would also affect the safety of that foyer area. And of course, the patients, there was 12 serious injuries, including broken teeth, concussion, and fractures, who were attended to by Dunedin Hospital. Now, in the Health and Safety at Work Act, a designer must take reasonable care that the structure would not put people at risk when they're using the building for the purpose that it was intended. So I think I'm not a lawyer, but it seems pretty clear to me that this does not comply with the Health and Safety Act. And sure enough, the matter was taken to court. The story does have a happy ending, and that Ms. Casey, who was the final victim of that hazard, had a sister who was a barrister, and she took the matter to court, and the judge ordered it to be repaired, the floor to be repaired. One way of overcoming defects is to ask why they happened and ask the 5 whys. Why did it happen? Why did that happen? Why did that happen? And so on. And that's one way to try and get at the problem. But I think these problems and hazards are relatively simple. So I'm not sure that that's the cause of it. And I'd like to take another approach. And part of that is to do with the reason that they happen. When I interview the project teams in these buildings, we're walking around the building, sometimes they'll come across a problem and they'll acknowledge it. And when they talk about the cause of it, they often come up with the same answer. And I'm wondering if you can guess what that is, or what you think the answers are. Why would a problem like this occur? I'll give you a minute or half a minute or so, a few seconds to just jot down some ideas. Just the first thing that comes into your head would be fine. And then I'll let you know what they seem to be saying most often. Aesthetics over function, thank you. Designers prefer the polished tiles. Yeah, well, certainly easier to clean. Hard surfaces. Yeah, more durable maintenance. Yeah. Designers prefer the look of the polished tiles. Yeah. So thank you for those answers. Yeah. Well, the thing that I've noticed very often in these sort of responses is that people will say it's the other guy's fault. I'll just close that down and advance to the next slide. They so often say it's the other guy. And that's perhaps a reflection on our fragmented building processes that we usually have. Everybody works for a different company. We want to blame the other guy. And that's, to a certain extent, that's understandable because we don't want to take liability for it. But that's not really helping prevent it from us creating these problems. And if we look at a more integrated industry, like, say, in the car industry, which is Toyota produces more than 10 million cars a year, so they have to have a pretty high quality to achieve such a thing. They have a culture of stopping to fix a problem. They actually have a thing called an and/or cord, which they pull over the assembly line to stop the assembly line if anyone finds a defect, and they all come together to fix the cause of the problem. They go and see the thing. So going to see is one of these Toyota quality principles. And that's essentially what we're doing in these building evaluations and making it visible. So we use a lot of photography to make any problems visible to future building teams that are working on new projects, and to avoid them being hidden in future, or avoid them being swept under the mat, so to speak. If we look at aircraft, though, one of the things that separates aircraft from smashing into the ground is the use of checklists. They've used them since 1937 for critical requirements in the complex process of flight. As in 1937, the Super Fortress was too complex to fly without using checklists. They're also used in medical surgery, where processes can be rapidly implemented. They can involve teams, such as the unscrubbed nurse here. You can see going through the checklist with the surgeon and the anaesthetist and the scrub nurse in the background. And they have a high level of compliance, which would be quite handy if we wanted to eliminate things like a slippery when wet entrance and be sure of eliminating it. What's recommended in developing a checklist is to look at the feedback, review the stages of the production process, so we can do that with building projects, use precise language in them, design them for teams, and then test them and test them and test them again. So I'd also like to ask the question, do the PCBUs, the people designing these buildings, do they know that the floors are dangerous, or do they not know that they're dangerous? Perhaps either. I think we have to cater for both possibilities. So it needs to have an educational component in it, as well as a way of ensuring that it doesn't happen again, or that these hazards are not repeated. So firstly, the process would be, I suggest, to look at the lessons learned and check those which are both common and serious. And I'm thinking both here about safety hazards and health hazards, as well as things that affect productivity or work. So I've set up this template for a checklist for such lessons learned. Firstly, you can see the title. It's put in the positive, a safe when wet entrance, identified the problem and the reported effects, which of course is injuries and falling. And then several examples to illustrate the fact that these really are problems that people are reporting in completed buildings, and they're important to the occupants. So nobody could ever say again that they didn't know this was going to be a problem. There is then, in the box, in the table at the bottom there, you can see a risk management process where firstly they're invited to assess the costs of that would occur should the hazard be repeated in a proposed building, both in productivity losses, disputes, etc., and also whether there is a safety hazard and a reputational hazard. So it's all made open and transparent. They're then invited to decide how they're going to manage the risk in one of those four ways: eliminate it, transfer it, reduce it, or accept the risk. And then describe how they're going to do that, and some sort of proof that it has been done. Essentially, that's just knowledge and care, which I think was once a definition of professionalism, so it shouldn't be too difficult to do. Now, I've tried this out, developed this, and tried it out in a prototype form with about 20 architects and capital works managers. And their responses to that were that, yes, their buildings were at risk. They thought that the risks that they were identifying would cost up to $5 million, plus safety and reputational problems. And they think it would be worth applying such a checklist. They also thought that the clients should be responsible for initiating this process. And when I asked them how many risks they'd like to, or how many lessons learned they'd like to apply, they said between 20 and 60. And of course, the results of such a process could be tabulated and graphed, like is shown here, perhaps with a traffic light system. So as a steering committee for projects could look at the risk exposure of known problems. And one of the nice things about that sort of template that I showed you is that once the issues are inserted, once the insertion is made, they can be compressed into quite a small screen size like this and summarized, such as on a smartphone app. Now, one of the early people to have informed the process that the government architect developed was the US Army Corps of Engineers. And that was some years ago, but just recently, a couple of years ago, there was an article in the Metropolis magazine saying that they are currently identifying a $77 rate of return for post-occupancy evaluations, and that is in saving money in the operations, maintenance and renovation costs of buildings, which is quite pleasing to know when we're thinking about applying a due diligence process with a checklist to eliminate them. So my final question for you is, do you think buildings that your family would use or you would use should be checked for common building problems before construction rather than coming along and evaluating them beforehand or afterwards? Okay, so that's good. That shows that I'm onto the right hunch here. People are mostly saying it's, or all saying it would be a useful process, so thanks for that. So now I'll move on to the next slide. And it's just to wrap up. There's some more information if you require it on my website, postoccupancyevaluation.com, and also at our company website at teamarchitects.co.nz. So I'll be pleased to answer any questions or discuss any points if you'd like to raise them.
Thank you, Chris. Yes, there are a few questions that have come through, and just a reminder, anyone else, please feel free to pop your questions in the Q&A. This did come up a few times in the poll there as well. A question here from Jonathan: if you design the surface rough, then won't cleaning be an issue?
Yes, it could be. Depends how it's done. It could be larger wicking and wiping mats, of course, and it's another way of doing it in some areas. So yeah, certainly some various things that have to be considered. Durability, cleaning, appearance are all issues in the surface of an entrance.
Great, thank you. Question here from Gordon: why do architects continue to design like this?
Well, my response is that because there's there's a lack of a checklist to prevent them. I guess most of these comply with the code, or they're at least deemed to comply with the code, and there can be a number of reasons for that. We can blame the architect, or we could perhaps in some cases blame the client who's wanting quick and cheap and low cost. But I think that the blame game is not helpful. We don't use the blame game when we're assessing various types of accidents, such as air crashes or mountain safety accidents. It's more assessed the case of how can we prevent problems rather than blaming a particular individual. I just don't think that's helpful because, we're just kind of going round and round in circles blaming a particular group without looking at the root cause of why it is or how we can prevent it, which is more important.
Awesome. That leads nicely into just a comment here from Chris. In their experience, is that the modern public footpaths are obviously too slippery when wet. The official response is always the surface complies with the standards for the footpath. They can only conclude that perhaps the standards are too low, and what are your thoughts around that? And there's another few questions that have come through just now actually, that should the codes be addressed for the risk there?
Yeah, yes, I think that perhaps the standard or the building code should be reviewed. I also think there's potentially a matter of the way it's used. There could be some sort of product, or oil or a cleaning product that has made a safe floor slippery. So it may be something in the use of it as well. But I think that footpaths definitely need some attention. And if you mean footpaths on streets, I'm certainly noticed that areas like in Wellington, there are a lot of slippery bricks around the pavements on city councils replacing asphalt and concrete with slippery bricks. And I think that's quite dangerous.
Absolutely. And a few questions like that came through, so obviously everyone of the same opinion there. We've got a question here from Lily. Thanks for the presentation. You mentioned that the design and the construction are quite a segregated process. The designer who specifies the tiles or surface material may not be purchased. Does designer always have the power to influence the procurement of the building material? And I guess any opinions or thoughts on how to, if not, how to perhaps do that?
Yes, well, I guess the building, the documents that go in for building consent from the designer will specify the exact product, and then the council is responsible to see that that exact product is installed, and then it will get a code compliance certificate. If a substitute product is put in, the council should identify that and decline a code compliance certificate.
Great. We'll just give it another minute and see if any other questions come through from that. I guess if you had a wrap up or something to take away from everyone listening today, what would you like to pass on in sharing from this?
Well, I think in summary, what we're doing in these evaluations is simply providing a way for all stakeholders, the staff working in a building and the project teams and the people visiting the building for various services to come together and discuss the quality of their buildings and how they can work better. These are generally pretty complex buildings, and we need to be able to do that in an efficient and prompt way, and find a way of making these generally pretty good buildings even better and improving them each year. So it's simply a way of talking about buildings effectively and efficiently to do them a little bit better each year.
Great, we've had a few more questions come through, so thank you for that, keep them coming. There's another comment here from Lily. Process safety, by the definition by IQME's Safety Centre, differentiates process safety from occupational safety. How would you comment on the difference between occupational and process safety?
I'm not 100% sure what you mean by process safety. I guess that's perhaps something to do with the way that whether the building is potentially usable in a safe way or whether it's misused later on in occupational safety. But I think we need to consider all of those things because of the long life of buildings and the variable conditions under which they're used. And I think that the broad stakeholder engagement that we use in these evaluations provides the diverse or reflection on the diverse experience that all of those people have. Hopefully. So I'm not sure if that answers your question, but I've done my best.
It's okay. No, that's great. There's a question there from Chris. I'm just hoping that you can see that from your end. It has a lot of code in it, so I might get you to actually read that one yourself, being the expert, if you could see that.
Yep, so it specifies a level of access routes, yep, and coefficient of friction, yep. And yeah, so I would say generally that the sorts of lessons
Just
learned that
quickly,
we
sorry, Chris. It's just us that can see the question, so would you mind reading it out just so everyone knows what you're answering?
Sure, yeah. So the building code acceptable solution D1 AS1 paragraph 2.11 specifies that the level of access routes used by a public need to have a coefficient of friction of at least 0.4. It refers to a standard NZS and Australian Standard 3661.1 1993 slip resistance of pedestrian surfaces for the method of measuring the friction coefficient is specified. Is the specified level inadequate? Well, I would suspect it is because it's not working. People are falling over, and whether it is or it isn't, I still think it needs to be given attention. And as I say, sometimes there may be other cleaning products or some sort of oil or something that's making it more slippery. It needs further attention, and that's perhaps something which applies more generally to the productivity and safety lessons learned from these evaluations. They may be things which are compliant or not compliant with the code. Maybe the councils somehow overlooked them in the code compliance system or not. But I think that that may be a solution to some of these products, and perhaps MB might want to look at those, some of those lessons learned, and refine the code over time. Hopefully that would happen.
Great, thank you so much. Well, it looks like no more questions have come through, so I think we will wrap it up there. We really, oh, maybe I'm wrong. Oh, we've just got a bit of reference here from Lily. She was mentioning that she was more thinking along the lines of process safety in the process plant or industrial scenarios, where the hazard identification and risk analysis are likely to be undertaken at early design stage, ideally from a life cycle approach. In the buildings and construction fields, is it common to have safety in design or inherent safe design at the early stages? I think system and procedures to provide a safety barrier compared to using engineering and design was to specify more on that question earlier.
Yes, Lily, I think that there on the larger projects there is often safety is addressed right through the design process, and that's important, and I think it is occurring to varying extents. But I think that the sort of process that we're doing here is still necessary and independent of that, because we still need to find the things that are slipping through the gaps. Because no building is, we've found yet is perfect. We're still finding defects that are slipping through, and that's what this evaluation process is for. And remember the PDCA cycle that we had at the start. So this is independent. These are the things that are slipping through that the project teams maybe not aware of or not successfully addressed.
Lovely. Thank you. Well, as I said, I think we will hold it there. Lily says thank you for that. We appreciate your time, Chris. I understand you've been travelling around everywhere doing some assessments, so we really appreciate your time in presenting here. And just a reminder to everyone that the recording will be on the Engineering New Zealand website in the near future, along with the rest of the webinar series recordings. Thank you everyone for joining, and once again, thanks Chris, and we'll see you all next time.
Thank you.